today should not be that long. We are come to a conclusion. I think I have distributed, uploaded most of the items that you get except for test 2 marks and also assignment 2 because it's just been there. And I know that there are a number of discrepancies between the what on the Excel. On the assignment 1, I think one of the question I did not put marks for the method, not just for one person but for everybody else. Yeah, I will do that. The marks for the method, but usually I will check those who get the right methods will get the marks for the proportion for the method, and those who got the right answers will obviously have full marks for that particular part. Now, in submitting the solution, I normally give the method, how it is being done, and obviously you cannot compare the answers in the solution that I give you with the answers that you get because of the different in data that is being done. So I can only give methods of the solution for one particular data, and the result might be different. There are, of course, some differences between calculations done using calculator, and if there are many steps involved and you start to truncate the decimal place at each step, and then the final answer may have some differences between those calculated by Excel, the one that I give you back, and those that is being keyed in or calculated by calculators. I try to minimize the error actually due to truncation, and that's part of the methods proportion of the methods in methods mark. And another difference might be if we are reading graphs, the value of stress concentration factors. There are some actually reading as low as 1.2 and some actually as high as 1.5, whereas the value for that is actually 1.3 or 1.35. So that caused quite a lot of problem there in terms of checking the answers. So I'm collecting any if you feel if the difference is very high, the way it is being checked, I have the accuracy check, certain percentage of acceptability. In other words, if it is purely calculation does not involve reading of graphs. For example, the Morse circle. The Morse circle is actually reading from the graph paper, and also the reading of the data from stress concentration factors. If that is the case, then the difference acceptability may be up to 5%, 5 to 6%. If it is purely calculation and doesn't involve any set, then usually it is about 1% acceptability. So there are some maybe some differences in there. But as I said, the method being done there. Another one is I think there is one student asking in terms of equilibrium of a free body diagram. I did mention that once you cut the free body diagram, and for you to choose the direction, the positive direction in the force. In some cases, I choose compression, the actual behavior of that. If it is compression, I put in compression. As drawn is positive. And if the answer turn out to be negative, then the direction is in the other way around. For example, for the tube inside a tube, I can't remember which question. If you cut, you can put positive tension as positive as tension in the free body diagram, and it is consistent throughout. And at the end of the day, you got the answer for that particular stress is negative, which is opposite to the initially assumed direction. Then the actual one is in compression, that kind of thing. So if it's consistently carried out, then it should come out right numerical answer. The direction will be either if it is the same as in your assumption, then the direction and the value is correct. If the sign of the value is opposite to that in the assumed direction, then the direction is in the other way around. So there could be looking at that, but I think at the end of the day, if it is compressive stress, it is compressive, whether you initially assume it is tension and it turned out to be compressive, negative value. If you initially assume that it is compression, then you will get positive value at the end. Positive, that means it is the same as your assumption initially. Negative means it is the other way around as you first assume in your free body diagram. So I'm looking at the understanding of equilibrium in most cases in that particular case. Okay, now we have 49 students. So if you have any query in there, I think to email me, and I'll collecting all the information, I'll checking the check there, but there could be some numerical differences. Another point or another one is actually there are quite a number of your side. Sometimes it is difficult to read your handwriting. Okay, and there's one major big that makes me quite slow down in checking your work because of your handwriting, especially numbers. I think make sure you write properly. Numbers 4 and number 7 might look similar. Number 7 and number 9 may look similar. And there are quite a lot of difference between 9 and 7. And especially when you are talking about units. So if you don't put the units, okay, you have a figure, let's say 10.2, you don't put the units, and I assume that the unit is the same as what the question one. Okay, if the question one, the unit to be in megapascal, you put in 10.2 and you don't put in unit, then I assume it is 10.2 megapascal. Whereas in your calculation, it is obvious it is not megapascal, but it may be in kilonewton per millimeter square or something like that. So that could cause, well, could cause your marks basically. If you don't put the units on correctly, it's the same as not answering the question correctly. So make sure you don't do that kind of mistake in your one more assessment or two more in your assignment 2 and your final exam. Okay. Normally we have a second person checking actually for final exam on the solutions, but your handwriting on the assignment on the test 2, there are about 5 or 6 students do not actually write your ID number on your answer script. So that poses a little bit of problem to track down whose script belongs to whom. Okay, when it is being downloaded. Normally, what I do, I download it and then put it in one particular folder, and then when we want to separate the whatever is being downloaded to the individual students folder, if you don't have any identification on that, that's cause quite a difficulty. Yeah, I don't have the liberty of fast internet at home. And also the amount of data, the maximum limit that I can download reasonably quickly is not that high. So normally I just download it at UCSI to get advantage of the fast internet. And then yeah, so basically to rearrange that. So in other words, if you don't put your ID on each paper and your file name only says /2, /2, /2, then there's no way we can know who belongs to whom. So we have to track back who actually sent it on CN. And that way, if you don't have a fast internet or using a hotspot of handphone when I'm working at home, that may take quite a while to actually work. So file name should have your ID number, and if possible, put your ID number on every page of your answer. If you think this is a difficult thing to do, you can prepare that early. You just get a set of blank paper for your blank paper now for you to answer and so on. Put on that sheet of paper every page your ID number. You can do it now, maybe 100 pages and so on. Then you can use it for every subject that you are taking. You don't have to wait until the day of the exam that you write your ID number on every page of your answer script. There are a few just putting there /1, /2, /2, /2, the same number, the same name. So yeah, that's the difficulty. You can see that. So handwriting, make sure your handwriting is legible. Okay, there are quite a number of cases, 3 and 5, 7, and usually 4, 7, 9, they all look almost the same. So use a proper, what you call, fine tip, not fine, at least medium tip pen to use. Okay, now we have about 58 now. So today is the conclusion of what we have done. Okay, yeah, we have opening introduction in the first day, and today is the last lecture day, and we'll have a conclusion. If you have, as I said, if you have any anything regarding I have your solution, so you don't have to resubmit your solution. You just tell which particular question and which particular what do you call that, question number. So I'll still be checking all those things. Okay, now is the you see the shared screen. Yeah, can you see the shared screen?
Yeah, can.
Is it visible?
Yes.
Yes, sir.
Is my voice visible?
Yes, but there's
Audible?
a little bit of echo.
Yes, sir.
Yeah, I do not know because I'm using a different room now, and I know there's another class next door. But this is the small discussion room outside our main office. Okay, so yeah, we have 58 something there. Okay, so in conclusion, so just to remind back, the reason why you need to remind back, because you got to check the timetable for the final exam. Look for EM317 stress analysis. You're registering for that. I know that there is timetable slot for this in the IIS. And the other one is BEM2043 mechanics of solid, I think in the timetable. I think one student saying that he couldn't find the timetable. I checked the timetable, it is there. Okay. So these are all this while, this is the course. Just to remind that the title is actually some elements of design in the title for EM317. So in other words, for if possible, the assessment should include related to the design aspect. Another one is mechanics of solid. It's more like theoretical type. So yeah, so those taking 2043 together with this is actually have the advantage of design aspect in mechanics of solid. Okay, now what we have gone through for the past 14 weeks, there is no mid semester break, so it's a continuous 14 weeks. We have 5 CLOs, and I think we have completed all of them. CLO1 on axial loading, CLO2 on torsion, we have completed that. CLO3 on beam, we have completed that also. And CLO4, we have completed. CLO5, we have completed. So basically within the time frame, and this is assessing the CLO against what we have done. It's not assessment how many percent marks and so on. Okay, this is assessing the CLO as prescribed by the course outline, and also the thing that we have completed. Now let's summarize what we have done, and hopefully this will give you some call it mind mapping, but I don't map mine. It's just what we are expected to know, and you can see that what we the subject matter is all about. For CLO 1 uniaxial case, we break that into 2 types. One is static determinate and statically indeterminate. So these are the two. You should be able to recognize which one is statically determinate, which one is statically indeterminate. Now for the statically determinate, you only need equilibrium of forces and moments. And the way to do this is actually to use it's a free body. You have to develop the free body diagram and the cut method. So these are the things there. So if you cut to form a free body diagram by cutting method, apply force and moment equilibrium, you can solve the problem. What is it that you want to calculate? Stress, strain, displacement, and extension. So if you can solve these calculated quantities using this, then it is statically determinate. We also have another type, statically indeterminate. You still need force moment equilibrium, but you need compatibility. Yeah, so this is an additional tool basically. And you still use free body diagram by cutting method, but to apply compatibility, these are the situations that you have to look for. Equal displacement, the same direction, there's one possible case. Equal displacement in opposite direction, I think we have a few cases on that one, or the proportional displacement type. So you should be able to recognize, given a certain diagram, If they, then you should be able to work out that whether it belongs to statically determinate or statically indeterminate. Loads, okay. I'll give some example later on this. For uniaxial case, we have mechanical loads which generate mechanical stresses, strain, and displacement. And the mechanical loads includes given value. In other words, is given a point load or distributed load. Some is not given the value, but is given the what is the component going to bear. In other words, the weight is going to work on. So this one we call it the from different sources. It's not point given. Okay, so it could be weight. Most of the time it's the weight, but I think we give you one example on the wind force that generate loads, mechanical loads on this system. And sometimes we don't give you loads, but we said we give you the limits of stress value. So it's not actually load. It's just saying that this thing is loaded. We have not discussed on that one. Another one that given is also thermal load. Expansion, thermal expansion will generate some stresses. So for uniaxial case, it covers these two. Just understand the difference between given load and loads that need to be calculated from different sources. And the related material properties for ClO1 is Poisson ratio, Young's modulus, shear modulus, and thermal expansion. So these are the four material properties. Section properties that you need to know, actually the area, cross-section area. You may have to know and calculate that. And another one is of course the length. Okay. And the calculated values, you should be familiar to calculate stress, strain from its definition, displacement, and extension. So these are what is in the ClO1 uniaxial. For ClO2, torsion case is much smaller compared to ClO1. The reason being there are a number of related item of ClO1 or of ClO2 has been dealt with in ClO1. Now for ClO2, we only concentrate on circular shaft, torsion of circular shaft. Okay, these are the scope in this particular outline. So this one you have to know in detail. Torsion of other cross section, I think you can read up in your textbooks and so on. Okay. For this one, it's statically determinate only, so that doesn't cover indeterminate cases. It is torque equilibrium. It's the one is equivalent to force equilibrium, also by cutting method. And you also need free body diagram, cut method, torque, force diagram, torsion, shear, stress. Not right, the torque diagram basically. Okay, torque diagram, in other words, torque at different parts of the shaft. And these are the technique that you need to use, and torsion, shear, stress. The loads associated with torsion work is usually mechanical torque. We don't cover any other type of torque. And where does this torque come from? It's either from given value or given direction. In other words, force acting at a certain location and so on. And type. Okay, so what are the type? It could be the torque itself. We said it is a Newton meter, give you torque, or it comes from power transmission information. You calculate the torque from that power transmission. So you have to understand force, distance, relationship with for torque, and you have to understand the relationship between power and torque, which is speed. Okay. Another type is calculated from different sources. In other words, it could be power transmission, it could be weights acting at a certain distance, it could be from power transmission as well. Okay, could be wind force, and in the assignment 1, I think we give you the wind force on that. Sometimes also from the limit of stress values. You may be asked to calculate the torque for maximum stress. So the torque is not given, but you have to calculate the torque for given stress. Now, material property related to this is only one, which is shear modulus. This is the only material property. Except that the shear modulus, sometimes it's not given as G values, but you have to calculate from E and nu. Okay, so these are the things that you realize. Section properties, J is the only section properties which is additional. Other one is actually area. Okay, so J, the T over J equal to G theta over L. What the calculated values normally related to this? If you need J, then you have to calculate J. That's obvious. The calculated values usually is torque, shear stress, and angular twist. Okay, these are the things that you should be familiarized with. CLO3, bending of beams. This one is quite long in terms of lecture and exercise because there are two parts. One is shear force and bending moment. That took up a little bit of length there because it covers so many forces. Now for this one, again, the scope of this particular course is it cover only statically determinate. It does not cover for this particular level statically indeterminate. So if you look in the textbook, you may not be familiar with from this particular course the equivalent to compatibility for bending of beam. So you may not be familiar because you're not being exposed, and because it is not covered for this particular level. In most universities, you have another level for statically indeterminate cases for beam, but for this case, it doesn't. And since it is statically determinate, the only conditions is equilibrium conditions, force and also moment. Again, you still need free body diagram, cut method for the shear force and bending moment diagram. And after that, you use bending equation for bending stress and transverse, you also need transverse shear. So these are the two quantities. These are the method used. Loads, for this particular case, for bending, we don't have, it's only mechanical load. We don't cover thermal bending. I think there are thermal bending, but it is outside the scope. And how does the load coming from? Given value. Either point load, its direction, or uniformly distributed load. This is the basic, the lowest form of understanding that you have to do. The next higher level, higher cognitive level is actually to calculate from different sources. It is not, that means you have to calculate the load, either from weights on that beam or the forces of wind and that kind of thing. So these are the level in which, based on the OBE prescribed, actually we should reach the second type of level. That's why in your in most of the example, assignment, and so on, it is not the type 1. Okay, it's not this type. It is at the second. And in some cases, as I said, is from limit values. Okay, so you have to be prepared for this kind of what you call problems to be solved. I'll show the different later on. The material properties related in this bending is apparently only Young's modulus. M over I equal to E over R equal to sigma over Y. Okay, if you compare the yield stress, then you have the yield stress there. But as far as applying equation or equation for the bending equation is the material properties E. The section properties that you need to know is what is I and determine I. Okay, M over I equal to sigma over Y. So that I. What are the calculated values that normally you are expected to know how to calculate is external load if it comes from sources which are not given load. Okay, it could be sources from the weight. You are expected to calculate the reactions. Okay, so these are the as a summarize for the bending. So they are the key items that you need to understand that. Okay. The next one is ClO4. ClO4, there are two main things that we are looking for. One is stress transformation. They are all stress transformation. Stress transformation via Morsel. And you are expected to know how to construct the Morsel. Okay, that's why in your test 2 last time there are two parts. One has to be a Morsel. I don't think you can run away from it. Learn how to draw, learn how to use the instrument that you use. Okay, to use. And what is needed from that Morsel information that you have to read or able to read from the Morsel is maximum principal stress. Know where they are and know where to identify. Minimum principal stress, maximum shear stress, and the plane theta 1, theta 2, and also sigma at a particular theta. Yeah, in fact, for the Morsel, it also cover Morsel for stress. It also cover Morsel for strain. Okay. So so at least these are the minimum that you should be able to know from Morsel. Know how to draw from the stress system given and know how to identify. The accuracy of these values that you obtain from the Morsel might not be the same accuracy as calculated values. You can calculate to check the Morsel, but it has to come from the Morsel. If you calculate, you got one particular value, but your Morsel is wrong, then you may not get marks for the Morsel. Okay, so you can check. The second part is biaxial stress, is knowing the constructing the system of that stress. So you should be able to demonstrate and understand from a given load condition, you determine the stress system for the element on that. So in other words, you may have to calculate in this particular part the shear stress, the axial sigma x, and the other sigma y from the given component under certain load conditions. So in other words, this is one step back. This the first part on the Mohr circle usually is you are given the stress system and translate that stress system into a Mohr circle to obtain this one. Whereas the second part is actually you construct the stress system first, and then you determine the value. Okay. Now this could be another Mohr circle. You can have, or it could be from a transformation equation. So both is acceptable. Okay. The first one has to have Mohr circle, compulsory. The biaxial stress you can calculate only without the Mohr circle, but the stress system has to be shown. Okay, you draw an element, show where is sigma x, how much is sigma x from whatever the given load. Okay, so these two. And what are the calculated values that is expected to know is, of course, maximum principal stress, sigma 1, minimum principal stress, sigma 2, maximum shear, and the related angle and so on. Okay, so these are the quantities that is expected for you to get. And lastly, column. Okay, column. I already uploaded exercise questions for column. Have you actually download those? Yeah, on CN?
Yes, sir.
Yeah, and also the solution for the last question. Yeah, because I think question number 4, if I'm not mistaken, because the earlier question is actually not much of an exercise. It's basically filling the numbers into an equation. Just P crit equal to pi squared EI over K squared L squared. And for different boundary condition, just put in all the values there in your calculator and you get P critical. So to me, not much OBE in there, except know what value to put into that equation. But I think the final, the fourth equation, the fourth question, I think requires some what you call thinking, and this course is about thinking. Okay, for column, what is expected on column? Again, in terms of type of problem, it is statically determinate. So the only example for statically indeterminate that you come across from this course is actually from uniaxial case. So in other words, equilibrium, forces and moment, that is the main tool there. And from there, what is expected to know is critical load. Now, critical load is not just knowing the equation. P crit equal to pi squared EI over K squared L squared for different, and what are the values of K for different boundary conditions. Not just that. But critical load is like the property of that column, because it is independent of external load. It does not depend on external load. It depends on the Young's modulus, which is the material property. It depends on the length, which is the physical size of the component of the column, and it depends on I value. So it's not depend on external load. So it is the intrinsic property. It's like yield stress. Okay, it's like that. It's like tensile strength. Critical load is like that. In other words, given certain value or certain column or beam of certain size, certain length, it has its critical load, whether it is being applied or whether it is being subjected to that type of load that will cause buckling or not, that's a different issue. But it is the intrinsic property of that length. So how do we utilize this critical load? It's not just be able to calculate P crit value. No, it is relate that value to a certain design situation. So that's what question number 4 for your exercise is trying to work on. Now, column is about compressive stress due to load applied or critical load. Okay, it's compressive stress. Okay, in other words, you have to know how to calculate compressive stress when a certain load is applied, and you should be able to calculate also even if the load is not being applied, you should be able to calculate the compressive stress at critical load, because critical load is not external load, it is properties of that column. And the other one is what is the idea of effective length, the distance between zero bending moment. Okay, so these are the work there. The loads, if some loads are applied there, is usually mechanical load only. We have thermal buckling, but it is not in this particular part of the course, thermal buckling. So it is a mechanical buckling. Now, where does the load come from? Now, it's either given value, or the question might be asking for critical load, or it could be calculated from external sources. The sources, usually the weight in this particular course, or from the limit values. So this is limiting the maximum load that it can carry. Material properties basically mostly involve is E values. The rest is actually the size, which is not a property. It's not material property. Length is not material property. Cross-sectional dimension is not material property. So P critical depends on the material property is E. Section properties that you have to know and able to work is IXX, IYY, because you have to check which is the lower value in order to determine P critical. The other one is area. Okay, in some cases, we have to calculate the compressive stress is force over area. Now, what are the values that is normally encountered in this case is the capacity, maximum capacity. In other words, if it is about column supporting liquid tank, okay, liquid tank, then we want to know what is the capacity of the tank supported by that column before the column buckle. So that's the capacity of the tank. So if we know the capacity of the tank, then we can put in overflow devices so that it won't go up above that particular level. Another one is maximum load of certain item or certain column that can be loaded up. The length of the column, the suitable length for design situation, the stress of the column, and the effective length. So these are the thing that might be should be able to know how to calculate. Not many equations involved in this, but maybe one or two. P critical, one equation. Capacity, maximum load, and so on is actually could be calculating volume, which you should be able to know. But In some cases, there are some problem in calculating certain volume. So make sure you are familiarized with how to calculate volume. Okay, volume of the shell of the component and the volume of the item or liquid inside that shell. So they are two different things. Okay, so these are the summarize all this that hopefully will help you up in strategizing your studies. Now preparation. This one is preparation in the coming 1 or 2 weeks, right? In terms of preparation for the final exam, in particular, your assignment 2 also, and the most importantly is actually preparation for your final year and also your co-op, because in some situation your co-op is actually is design based. Now make sure you familiarize yourself with calculating volume of containers. Okay, what are the containers that you normally come out with? Cube type or rectangular section type. Cylinder, you must be able to calculate cylinders, volume of cylinder, volume of sphere or hemisphere or cone. Okay, so these should be able to be familiarized. Understand what the formula means if you wish to remember that. Know how to calculate weights of liquid in containers. So where do you calculate the weights? Rho G times volume. So that's the weight of the liquid. Okay, we have given you some examples on how rho is being used. Know how to locate the location of centroid of common shapes. You see this one rectangular rectangular shape. You see when you have the triangle type of distribution, load distribution, you need the representative point or the centroid in order to apply your equilibrium and so on. So the most common shape is rectangles and triangles. So these are the things that you have to be familiarized where they are. And for the Mohs circle, know how to measure angles using protractor. Okay, I know it looks simple, but I know not very often we actually measure angle, but for this particular case, you really need to measure the angle using protractor, especially for your Mohs circle. So that's the preparation. Some knowledge preparation, some is actually skill preparation. Okay, if you forgotten all that, there is time to check. There is time to look at formulas from whatever books that you have and familiarize with those. Now, just want to look at example 1. Okay, yeah, this one actually many students complain. I know last few lectures ago, few weeks ago, some says they find it very hard, right? Now, I just want to show some example of different cognitive level in this particular course and which level it is expected from you, from those attending at year 3 bachelor degree engineering program. You look at example 1. Okay, this example 1 is what you have in your exercise. What we do, example 1, we give you the beam. Okay, what type of beam? Simply supported beam. Whatever shape, it could be U shape, I shape, and so on. Okay, the type of section, because I values depend on the type. The physical length, 5 meters, for example, and the type of load, point load, distributed load, and so on. For this one is distributed load. So we give you this diagram type, right, in your exercise, and we just indicate where it is being supported at A and B, simply support, and these are the load all along there. And your exercise will give you determine the reaction force, V and M diagram, shear force and bending moment diagram, and calculate the stresses. These are the standard questions there. Right, we go above higher, slightly higher cognitive level. If you are given this type of example 2, for example, okay, what is this U shape beam? So this is the beam, length 5 meters, and it's given the total load there. Remember this test 2, right? Some parts of it look like this, and it gives you the total load value spread over a certain length. So in this case, spread over the whole entire length. Now in this case, there's it's not the same as this, right? This one, everything is given. This one, you need some thought about it. What type of load they are, and how to represent that load. So in this case, what you need is, it is total load 49.5 kilonewton distributed uniformly. Okay, so that's the. So what you do, you have to calculate the load per unit length. So you take the total load divided by total length, you get 9.81 kilonewton per meter. After that, you develop this model for this type of solution. The model solution for this type of problem. Okay. Now, is there any difference between this model with this model? They are the same. In other words, the method of solving it is the same. It's the same model, and it is the same thing there. But this is additional step that you need to work on prior to this particular model. Okay, and from there you determine the reaction forces, V and M diagram, and also the stresses. Now the number of steps become more, but the model for the solution is the same. Okay, the third example is this one. It's U-shaped beam, cross section 1 meter by 1 meter, length 5 meter, okay, and filled with water, or filled with liquid, or in this case water. And the density of water is 100 kilogram per meter cube. Right. Now it requires more thinking, right? One, to imagine. If you are given this diagram, is good. If you are not given the diagram of what happened, then you have to sketch the story behind this question. So this is the beam, U-shape, 1 meter by 1 meter, cross section, and 5 meter long. And it is filled with water. You know, the green liquid there is water. So what you have to do? You still need to develop the model for the load, and you may need to calculate the weight of water from rho GV. So rho is 1000, G 9.81, volume is 1 times 1 times 5. That gives you 4090 Newton or 49.05 kilonewton. So this is the total load. Not given, but give you the where does the load come from in this particular case. Now this is the total load, and you have to calculate the spread of the load because it's distributed. Once you calculate the total load, divide by the total length, then you get the load per unit length, 9.81 kilonewton meter. Then you calculate reaction V and M. V and M and stresses. Now you compare, once you get this value 1 and 2 calculated, then you build the model for solution. This is the model. It's a beam, distributed load, 9.81 kilonewton per meter. Now, is it different from example 1? The model of solution? It's the same, right? So it is the same problem. Okay, it's the same problem. So this is the model for the solution. So you can see that all three examples appears to be different problems, but the models to solve are the same. And this is how is expected from a year 3 mechanical engineering student. Okay, so make sure you understand that principle. Okay, so now example 3, there is some relationship to design problem compared to example 1. So this is not related to entirely not related to design, because yours is stress analysis and design, and this is related to design because it's not given, the load is not given how many kilonewton per meter, but you have to calculate from the design and application situation. Now this is what it's all about. Now this is how this being calculated. One way of calculating uniformly distributed load. Another way of a more general way is, let's say for this particular problem, another way of determining load per kilometer, load per meter or load per unit length, we call it. Now this is the same problem just now. We just identify where it is supported at A, halfway through at B, and another location at C. And we normally put the distance we measure from A into this direction. Okay, this is the X direction. So we can assume that at A, X is 0, at B, X is 2.5 meter, and at C, it is 5 meter. Now we are looking at another way, alternative way, which is slightly more general of determining what is the load per meter. Now, the alternative way is you calculate the load per unit length at A. In other words, at X equal to 0, okay, which is 1000 times 9.81 times depth times width at X equal to 0 to get that Newton per meter. So in this example, at A, rho is 1000, G is 9.81, and the depth and the width is 1. So I should have 9.81 times 1 times 1. Okay, so that is 9.81 kilonewton per meter. So this is the value at A. Now you calculate midway, the load per unit length at B, which is 2.5 meter from A. So at B, we check the situation there. The depth is still 1 meter and the width is still 1 meter because it is a uniform section. It may not be so. Okay, at B, we calculate the load per unit length, which is 1,000 multiplied by 9.81 multiplied by 1 multiplied by 1 is 9.81 kilonewton per meter. And then we calculate also the value at C, okay, which is x equal to 5. So from there, we calculate 1,000 because at C, there, the width is still 1 meter, the depth is still 1 meter. Because the cross section is uniform, 1 by 1 by 1. So at C, it is 9.81 kilonewton per meter. Then you can plot a graph. I'm not going to show the graph here. So the graph of W versus X. And for this case, it will be 9.81 kilonewton per meter all over entire beam. Okay, it's either this method or this method. Okay, so that's how. Once it is done, now this is related to design, right? Because it is a design of some sort. It is not just a what do you call that? Theoretical exercise on this particular beam. Now, the related to design, actually you relate to the application. So once you achieve that, then just use the normal model. So this is model for solving the problem. Now this is the problem related to design that you actually need to solve. So see the difference now between having this to solve or given this to solve. Now this is the different level of cognitive requirements. And EM 317 for being a year 3, this is the expected level from year 3. So it involves quite a additional at least 2 steps before it's actually calculating the reactions, determining V and M and determining the stresses. In your exercise, the model is already given, okay? But towards the later part, your assignment is actually looking at relationship to the design, stress analysis and design. Okay, now let's look at your exercise on question on column. I will upload the exercise question first. You have it on yours, right? Okay, this is the question. As I said, question number 1, you just take the equation and fill in the blank. It's given B times D times L, you get calculate I from there, I values, and then put into the critical load equation. So it's not quite a test. It's not what do you call that? It's exercise to give you the value. Okay, the application type related to design is these are the different boundary conditions, different K values for the same equation. Just put it in. Now if you look at this one, Okay, this is the cognitive level that is expected. Storage tank supported by 4 hollow columns. The diameter 4 meter, and it is used to store liquid with mass density 2500 kilogram per meter cube. Each column is hollow with size 100 by 100, which is a square, and 5 millimeters thickness. Okay. Now we have to assume something. This one is given. Empty tank is weightless. In other words, you ignore in calculating the length of the column to cause buckling, that you have to use you need to assume that the weight of the tank is not there. There are 4 columns, so it's assumed that each column carries equal load, and another one is the legs are clamp free condition. In other words, clamp at the bottom and free at the top where the tank is. Okay, so now at first it is not clear what is the question, right? Yeah, so if you read carefully, this type of arrangement, we have the liquid to be supported. Okay, and we have beam of this size. Okay, and we want to know what is the highest length, or what is the highest the level of the tank where we can place using this kind of beam section that we have, because there is no length in this particular beam. In this particular question, we are asked to decide what is the highest level of the tank. Okay, so with that question, go back to this slide again. Okay, just wait for a few seconds before you can upload. Yeah, you got it? You see the screen now?
Yes, sir.
Is it visible?
Yes.
Yeah, so this is the question. You see that? The tank size is given. So that means external load is given. And there is only 4 legs on this 4 column to support this particular tank. And the cross section of the column is weak. This is the column that we have in our store. Basically, we don't have any other cross section size, but we have a choice of the length, and we want the highest, the tallest arrangement. That means the what is the length of that, and so on. So in this situation, I'm not going to write anything, just to explain what is the problem is required there. We have the external load, which is the weight of the tank, the weight of the liquid in the tank. So that means you have to calculate the weight of the liquid, because that's the design requirement. So the liquid should be filled up in this particular tank of this particular size. So it has its weight, so to be supported. Now, 1/4 of this weight is to be supported by the column, 1 column. Okay, 1 column will support 1/4 of the weight. So in order to calculate the length, that 1/4 of the weight of the column of the liquid is the critical load of the column that we want to use to support it. Okay, if you use longer length, it will definitely buckle. So you have to calculate what is the maximum length that you can use in order to support this tank with the liquid in it full, and you have to decide on the length so that it doesn't buckle. So that's what the question is all about. So if you look at the solution, okay, so because these are before this I got so many questions on what the question is all about. Okay, it's maximum length to cause buckling, because it is slightly different from all other question above that. Okay, now sketch the situation, understand the problem, then you can start solving the problem. Okay, once you understand that, so this is how it is being solved. I just explained the solution first, where it come from. Okay, make sure you try to carry that out. Good. Okay, so this is the solution. So it doesn't take that long. It's only 2 pages. So got the solution. I think you have already got that, right? What you need to do is just to calculate the weight of the liquid in the tank, and then the critical load will become the total weight divided by 4, and equate that this load with the equation for critical load of the column with this particular size, and then from there you get this particular equation. So put in the value and you get the value of the length there. So this is how it is being done. Okay, but understand the problem. So the critical load at this particular case is the load is going to support. What is the maximum that each one can support? Okay, you can. So in this case, it is the length which is required. If the length is known, critical load is known, then you may have to limit the weight of the liquid in the tank. Okay, let's say in the situation where you have the length, you have this particular cross section, then what is the weight it can carry, then you decide on that one. If it is not enough, then add more column. Okay, I think that's all to conclude our course, and hopefully you are doing well in this difficult course to follow. I try to make as much as possible for you easy to follow within the capability of the technology and so on. Initially it was meant for face-to-face, but with the pandemic it become face-to-computer type, right? So okay, with that I will so there you are, what I have explained just now. Right, so the maximum liquid weight is actually the critical load required, and the maximum liquid will be P critical times the number of column used. So in the question there it is 4. So this is how it works. This is the condition of the way to calculate that column length, column height. It depends on the situation. If you are given, if the column length is given, then you may decide on how much. If it is column length given, the number of column is also fixed. In other words, you don't have that much beam to have the spots only 4. We don't encourage 3. It is 4 there. Then you limit how much, what is the level of liquid inside that tank. There's another way of doing it. Okay, so with that, I have to end. It's not introduction, it's conclusion. Okay, and the conclusion for the course. I said I'm picking up all your responses from that exercises, or not exercise, from assignment 1, test 1, and so on, before I finalize the marks there. Okay, so any questions?
Hi, sir.
Right.
I also found some error in the test 2.
Yeah.
Yeah, for your data in Excel for question 2B, the A is not exactly the same like what you did in your CN solution.
Oh, as I said, the CN solution is not solving your problem.
Yeah,
it is showing the method of how to solve, because
yes,
each has got different. Yeah,
because I'm using exactly your solution.
Oh, okay. You're redoing my solution, is it?
Yes.
Yeah, okay.
Yeah. So it's Q2B and also Q3. Question 3. Question 3, you are not using the same dimensions from the test question. And I saw your CN solution, you divided by 4 for the load. But in the test question, you mentioned that each carrying column, which means we do need to divide by 4.
Yeah. If the question says each carry how many kilonewton, then it is for that one. If it says the total is so much and each carry equal loads and there are 4, then it will be divided by 4. Okay, what I mean? Yeah. So it depends on the questions. Yes.
Yeah, so hope you recheck on the question 2B and question 3.
Yeah, I think that I know the reason why. Because that was when we draft the question and I tried to remove ambiguity. So initially we give you the total load and total number of column, but when I read the question, it may be ambiguous. So the solution was made for that. So, but we change the question so that it's calculated based on 1. Okay, I'll recheck and then and do it again. But I think so that there are whatever the case is, the solution actually is work based on the questions of test 2. Okay, anymore? So it is the question on the test is not reflected in the solution. Okay, all right, thank you. So I'll check that one again. Any more? The one that you do in your test is what is in the question, right?
Yeah. Never mind, I will send you an email later. Yeah.
No, because you already submitted your answer your answer script, right?
Yeah.
I'll check your answer script. Okay, so any more? I will upload this because I got all the yellow thing inside this conclusion slide, so I have to remove that yellow thing and then put into PDF. Then I'll upload it in CN maybe later tonight. Okay, so anymore, just take note of the my comment there about handwriting, numbers and so on. Make sure it's legible, otherwise I key in the wrong number. Okay, any more?
Sir.
Yeah.
For assignment 2,
right.
Do we take the tank as a point load or a uniformly distributed load?
Assignment 2, let me check. What is the question say? It is what a tank. Oh,
Yeah.
okay. And I know what I mean. Let's see. Simon 2. Where is it? Okay, just sharing it. Yeah. This is one, right?
Yes.
Yeah. What does it say?
Do we take the tank as a
No.
point load
Just
or?
look at the question there. Look at the question first. Okay, installation of tank. Spotted on 2 beam. Yeah, I can see that the tank is flat bottom, right?
Yes.
Yeah, so in other words, it is not point load.
Okay.
It is spread over this length.
Yep. Understood, sir.
Yeah.
Okay, then it clarifies my question already. Thank you.
Right, yeah, okay.
Okay.
Alright, any more?
How to find the part just now?
Which part?
This you said that
Yeah.
it's not point load, right?
Well, as I can see, it is not point load. It
Yeah,
is
so
distributed, yeah.
we just use the weight of this tank and then divide by the meter.
Well, it doesn't cover the whole length of the beam.
Yeah, it's just the small
Yeah, that,
part of the length, so we
yeah.
just direct divide by the length.
Yeah, it's because there are 2 beams. So in other words, one beam carry half.
Yeah, so we
Right.
need to divide the weight into 2. Then we
Right.
need to divide the length where the tank sit on the.
Yes. Yeah.
Okay.
Okay. Any more? No? Not, we can, yeah, I can call it a day. I hope you are enjoying the course. I don't know. You have to suggest ways so that I can improve. I was asked to teach this course again next semester. I hope I don't see you again in this particular course as repeat, okay? Yeah. Any more question? Yeah, the date for the deadline for the assignment 2 is next week, Tuesday. Okay. So those who are celebrating Ramadan, then I wish happy Ramadan. Yeah, wherever you are, in Malaysia or in your own country. Okay, so thank you very much.
Sir,
Yeah.
can you talk about a bit about the final exam, like how it looks like? How
Oh,
anything?
it covers all CLO.
Yeah, I know, but like how it will looks like same as test one, test two, like the level of hardness, anything, like the time will be if the time is going to be okay or it needs more time. Because really,
Uh,
like, sir, really question test two, really, sir, it will not. Yeah, the time is not enough. To be honest, like I'm really honest with you, the time is not enough at all. And
oh, I
really,
see.
not, it's really not my only problem. Like everyone I think have the same problem.
I don't know. I think if there are a longer time to be spent actually on question 1. I think on the Moss circle is drawing the circle. I don't think that's much time, is it?
Yeah, question 1 was more.
Yeah,
need more
yeah.
time.
The question 1 took a bit longer. I understand. As I said in the summary just now, the beam, yeah, they've got a lot to do. But for the torsion and for the Moss circle, I think should not be as long as for question 1.
Okay,
Yeah.
sir. If the first question take a lot of time to solve, so the remaining won't be enough to solve the remaining parts or the remaining questions.
You have the choice to answer question 2 first, right? Yeah, you can answer the question 2 first.
There is the same problem. The problem is with the time, not with the question. Like if I start with the second question, also I have a long time to solve the first question.
Yeah, true. But the second question, it doesn't take as long time as question 1, right?
So you suggest to start with the easiest one. So to solve question 2 and 3, if we still
I'm not suggesting anything.
No need.
Yeah. So by now, after doing all the exercises, after doing the test 1 and test 2, you should be able to realize where you can usually which question you can fast basically in terms of answering. It doesn't have to be question 1 first, second, third according to that order. You may have to submit the papers or the according to the order, but if you are writing on the loose paper, you can answer whichever question first, right? And then when you want to upload it in the PDF, you arrange it so that first question is the first and so on. I do not know. I think by now you have already by the 3rd year you already gone so many exams, and I do not know how you strategize your exam. But as far as this course is concerned, I think you should know which particular exercise that you can do fast, which particular one which take longer, and so on. So I think you in total then you should be able to. I'm not hinting anything, but on test 2, I'm sure your Moss circle and whatever there is only about 2 pages, right? The circle is 1 page, 1 graph paper, right?
Have you seen the comments for the exam for the test 2?
How do I do not know about the final exam, but test 2 is already up. You already done it. That's why I can comment on the test 2.
Yeah, I know that, but most of the students complain about the time. The time is not enough.
It's what I said. Time for question 1 took longer compared to question 2 and maybe question 3, right? Yeah, you don't have to start with question 1 all the time. By now, you should be familiarized by looking at the question and so on, which one that you are more competent in solving it in a shorter time. That's what I'm saying. Is you know your strength on a certain question and so on, and you know which one to tackle first, faster, and then you go on to some other question. Okay. I do not know what is going, or what question 3 final exam going to look like, but when I look at question at the second test and also first test, there are some questions which took a little bit longer, but there are some questions that took shorter time. So just plan your exam time and your test your exam time. Yeah. How many pages you do for your question 2? Only 2 pages, right? 1 graph. I can see from what you submitted, 1 graph and another sheet, another yeah, right? Anybody have got more than 2 graphs? Graph paper? I don't think so. Yeah, okay. Yeah, noted that other exam is much easier. No other exam also has not been conducted yet. It's after next week, right? All exam. Yeah, this week there's no exam yet. All tests. Okay, so it's already 6:30. So I think I will call it a day, and thank you very much. Right, so I will end this. So I'll end the meeting.